In this video, we will continue discuss topic 3 for subtopic 3.2, Principle of Conservation of Linear Momentum. So this principle states that for an isolated system, the total momentum is conserved, provided there are no external forces acting on them. Mathematically, for an isolated system, summation P initial equals summation P final. In any collision, there must be a conservation of linear momentum. So, what is a collision? Whenever an object in motion comes into contact with another object, we can call this event as a collision. There are two types of collision: elastic collision and inelastic collision. So, collision can occur in one dimension or in two dimensions. For all these collision, it will obey this principle. So, firstly, we look at collision in one dimension, where collision only occur along the same axis. Since the momentum is conserved, so we can apply this principle of conservation of momentum. So, at this slide, it's showing two examples of collision. So, for example 1, we have two objects moving in opposite direction and then collision occur. After the collision, both of objects will moving at the same velocity. Then, here, this is the equation for conservation of the momentum. For example 2, it's showing two objects moving with their own speed at the same direction, and after collision we can see both objects are moving in opposite direction. So by apply the principle conservation of momentum, so we can get this equation for this system. For collision in two dimension means we consider two components, x component and y component. So here we must conserve the momentum component by component. To do this, we set up the coordinate system and resolve the velocities into x and y component. So the momentum is conserved in two dimension collision. How to determine whether elastic collision or inelastic collision? So firstly, we look at elastic collision. For elastic collision, the total momentum and total kinetic energy are conserved, which means summation momentum before collision and after collision is equal. Same with total kinetic energy. Okay, look at this example. We have two balls that moving in opposite direction. Ball 1 with mass m1 moving to the right with initial velocity u1, while ball 2 with mass m2 moving to the left with initial velocity u2. And then both balls are collide each other. After the collision, we can see that both balls are bounced off away from each other with their own velocity. For ball 1, it's moving to the left with final velocity v1, while ball 2 moving to the right with velocity v2. So for this is what we call elastic collision. When apply principle of conservation of linear momentum to calculate the total momentum before collision is m1 u1 plus m2 u2, and for final momentum we can calculate using equation m1 v1 plus m2 u2 v2. So question here, for this case, we should be consider the direction of the velocity. If the ball move to the left, negative sign must be included during substitution value. Then, the total kinetic energy before and after collision, we can be calculated by taking the summation of each ball. For kinetic energy for ball 1 is half m1 u1 square plus half m2 u2 square. Then we proceed to the inelastic collision. For inelastic collision, total momentum are conserved, but total kinetic energy are not conserved. So we refer at this diagram. We have ball 1 with mass m1 moving with initial velocity u1 to the right. Then we have ball 2 with mass m2 in stationary state with mean initial velocity u2 equals 0. Okay, after the collision, we can see that both balls are stick together and move with the same speed. Then we can calculate the total momentum inertial by equation m1 u1 plus m2 u2. For the final momentum, they are given by summation mass for both ball m1 plus m2 times with v. So since the total kinetic energy are not conserved, that's mean the kinetic energy is converted into another form, such as sound, heat, or internal energy. So question here, it is a common misconception that the only inelastic collision are those in which the colliding bodies stick together. In fact, inelastic collision include many situations in which the body do not stick. Now, we proceed to the example form. How to apply this principle? Okay, question. We have a 200 gram tennis ball moving with a velocity of 15 meter per second along x-axis, collide with a stationary ball of 800 gram. After the collision, tennis ball is scattered at an angle of 45 degree from its original direction with velocity of 5 meter per second. Find the final velocity, magnetic and direction of the struck ball. So firstly, we visualize this problem. So we have both ball in x-axis before collision. So after the collision, we can see that the collision is involved in 2 dimensions. So we need to consider momentum in component x and y separately. Okay, since we need to apply momentum for both components, thus first step we need to resolve velocity into x and y component. So for v1, we have v1x to the right and then v1y upward. While for v2, in component x, we have v2x to the right and v2y downward. So question here, direction for object that move to the right and downward, to the left and downward, we must insert the negative sign. Okay, then we write down the concept physics that related. Summation p x component before collision is equal with summation px component after collision. So look at this diagram. We have m1 u1 plus m2 u2. Then after collision, since the collision occur in 2 dimensions, So you must resolve velocities into x and y component. So in x component, we relate with v1x. So we resolve, then the equation for momentum for ball 1 is m1 v1 cos theta 1 plus with m2 v2 cos theta 2. Then we substitute value. Then we simplify, so we get v2 cos theta 2 equal with 2.8661. Ni is for equation 1. Then we solve it in y component, momentum along y axis. So since the collision only occur in x component, so no component, 0 momentum for y component. Then for final, we have m1 v1 sin theta 1 plus m2 v2 sin theta 2. So here we can see that v2y with direction downward. Then we should put negative sign. Then we get v2 sin theta 2 equals 0.8839 for equation 2. Then we divide equation 2 over 1. So we get the theta 2 17.14. So this is the direction of the struck ball. By putting theta 2 into equation 2, then we solve it. So you can get the value of velocity for ball 2 with value 3 meter per second. So you guys can try this question. Then end of the topic 3, and all the best for you from both of us.